Okay, question 6 says, in the figure below we have triangle SPH is the midpoint of PH and F is the midpoint of SH. If H and S are collinear, meaning that they are on the same line, use the triangle below to answer the questions that follow. Right, so on the top right here I have the formulas that you need to know. This one, and this one. They will not be given to you at this stage, so you must remember these three. This last one is not unfamiliar, you've been using that one, and so you really just need to remember the middle one and the one on the right. Okay, so let's start. Question 611. Calculate the coordinates of E, the midpoint of PH. So we will now fill in this once we find it. Because we're working with midpoints, we need to work with the formula in the middle here. Right, so let's write that down. Alright, so the midpoint of PH, which we know to be E, we get by taking the x of P plus the x of H. So we go minus 1 plus 3 all over 2. And then we take the y value of P plus the y value of H, which is 2 plus 0 all over 2. And therefore the coordinates of E would be at 1 and 1. Now before we write it in, you need to take a second to see if your answer makes sense. So your calculation says that E is 1 and 1, and that is possible, right? Because we're saying that the x value here is 1 and the y value here is 1, which it could be because on the side we have 3, right? So we got the coordinates for E at 1 and 1. The next question is to find the gradient of HF. So we need to use equation number 3 over here. So to get the gradient of HF, we can say YH minus YF all over XH minus X of F. We then substitute these values. So the Y value of H is 0 minus the minus 1, and the X value of H is 3 minus the 0 of F. Right, the gradient therefore comes to a value of 1 over 3, and that is our answer. Now as I write it in, the gradient is 1 over 3. This makes sense because this is an increasing line, and so this should have a positive answer. The next question is to show that the value of y is negative 2. So we need to prove that this value here is a negative 2, and I'll show you how we can do that. Okay, so at this stage we have the coordinates of E, we have the gradient of FH, and now we need to find the coordinates of S, or rather the y coordinate of F. In the information, they tell you that F is the midpoint of SH, so we have another midpoint here. Okay, they also tell you that F, H, and S are collinear. So to answer this question, you basically have two options. You can either use the midpoint, or you can use the fact that this gradient of Fs is also a third because it's on the same line. So I'm going to show you both ways. The first one being using the midpoint. Righto. So the midpoint of minus 1, the y value over here, so this minus 1 came from saying y plus 0 over 2. Okay, and so the y coordinate of your midpoint, right, came from saying y of S plus y of H over 2. Okay, now we have the y coordinate of the midpoint, it's at minus 1. So minus 1 came from saying y plus 0 over 2. Okay, because here's the y value of S and here's the y value of H. From here we can just cross multiply to solve for y. So we can go minus 1 over 1 equals to y over 2, and then we cross multiply and find that y is equal to negative 2. And I think that is the easiest way, is by using the midpoint. The second option, not to restrict you, is using the gradient. So the gradient of S or Fs is the same as the gradient of Fh, and we know this because the points are collinear as mentioned up here, right? And so therefore the gradient of Fs needs to be 1 over 3, which we found earlier. And now we just have to substitute by saying yf minus ys over xf minus xs equal to a third, and from here we will solve, which I will do quickly. So I've just gone and filled in the values. So now we have minus 1 minus y over 3 equal to 1 over 3. We now have to go ahead and cross multiply. So 1 times 3 is 3, and then we need to multiply 3 with minus 1 minus y. So this works out to be minus 3y, and then what we can do is we can bring the 3y to the left, take the minus 3 or the 3 over, so that 3y is negative 6, making y negative 2. Okay, personally I like this option, but this one is also right? So you have successfully proven that the value of y is minus 2, and so we now have this point S as minus 3 and minus 2. Okay, the next question is to calculate the length of PS, and so we need to use distance formula here, and so we can say that PS is going to be the square root xp minus xs squared. You could have put s first and p second, doesn't matter, plus yp minus ys, right? If you start with p here, you start with p there as well. Then we just need to substitute. So let's try and do better with this one. Okay, so the x value of p is minus 1, the x value of s is minus 3, so this is minus the negative 3, and then we square that, plus the y value, which is 2, and the y value of s, which is negative 2, and then we square these values, and so we find that we end up with the square root of 2 squared plus 4 squared, which your calculator will give you as 20. Now I would say to leave your answer in surd form so that you don't miss out on any of the decimal values. And so now that we have the length of PS, we can actually go ahead and fill that in with yellow. So PS is root 20 units. Very important to write that unit because you might confuse it as a gradient, right? So now that that's done, the next question is to calculate the gradient of pH. So pH is the segment over here, right? And based on the slope of this line, we expect our answer to be negative. So we go 615. The gradient, small m, of pH, we can say yp minus yh over xp minus xh. Okay, y value of p is 2 minus 0 all over minus 1 minus 3, and then we end up with 2 over negative 4, which is negative a half. So I've gone ahead and filled that in. The gradient of pH is negative a half, and that checks out because we already determined that this needs to be a negative answer because this function or this line is decreasing. The next question and the last one is very popular because you need to use your knowledge of gradients to prove if a certain triangle could be a right-angled triangle. So the question here says that we need to prove that SPH is a right-angled triangle, meaning that it's true, you just need to show it. Okay, so let's clear the board quickly. So what we are trying to prove is that this angle here is a 90-degree angle, and to do so we need to show that PS and PH are perpendicular. So this segment here and that segment there, we are trying to show that they are making a 90-degree angle. So I would start by writing that down and saying that we want to prove, required to prove that PS is perpendicular to PH. And of course, you know, to prove this, it's a matter of multiplying your gradients, and if you get -1, then the two lines are perpendicular. Right, so we have the gradient of PH. We just found it in the previous question, and so the gradient of PH is -1/2. What we don't have is the gradient of PS, and that is what we are going to do now. So the gradient of PS, we can say YP minus YS over XP minus XS, and then we substitute. Okay, after substitution, we end up with 4 over 2, which is 2. So the gradient of PS is 2, and the gradient of PH is -1/2. Now that we have that, we can see that when we take the gradient of PH multiplied by the gradient of PS, we end up with -1/2 multiplied by 2, which is -1. This here tells you that those two segments, which I have in rainbow colors on the left, those two segments are making an angle of 90, right? And so the conclusion is that segment PS is perpendicular, making 90, with segment PH. You've just proven that. But the question is to prove that the triangle is a right angle triangle. And so now you can say, therefore, triangle SPH is a right angle triangle. Please don't say rat. Why? Because angle P is equal to 90 degrees. And there you have it. This is done. That's all you needed to do here to prove that this is a rat. So firstly or lastly, what we did was we had the gradient of PH. We found the gradient of PS. Then we used those gradients to show that this is 90 degrees. And using that fact, we could say that this is a right angle triangle because we have that 90-degree angle in the corner. Thank you for watching.